All right, guys, this should be the last video for this week. I think we'll get through everything. So this guy's real similar to one we did yesterday. A little bit different, but give you another example. So again, we're looking for what point, okay? So that means we're definitely looking for an x-coordinate and a y-coordinate. Okay, so we want to know when will the slope of the tangent line to this function be equal to 12. So we know if we take the derivative, that gives us a function that supplies us with the slope of the tangent line. So if we take the derivative here and just set it equal to 12 and solve for x, we'll have our x-coordinate. Okay, and then we can just go back and substitute whatever our x-coordinate is here to figure out what our y-coordinate is. Okay, so we've got to do dy dx. Okay, so let's see. Okay, we would get a to the uth power, so 3 to the x minus 2 power, times the natural log of the base, times the derivative of the exponent, u, which is just 1. And then obviously when we take the derivative here, we'd get minus 0. Okay, so right here I'm just getting 3 to the power of x minus 2 times the natural log of 3 as our derivative. Now we want to know when is that derivative going to be equal to 12. Okay, so we have to set this equal to 12 and then just solve. Okay, so I get 3 to the power of x minus 2 times the natural log of 3 and set that equal to 12 and then solve for x. Okay, so natural log of 3 is just a number. It's just a constant multiplier. So we divide both sides by the natural log of 3. So we get 3 to the power of x minus 2 equals 12 divided by the natural log of 3. Okay, now I want to get at that exponent because that's where my variable's at, the x. I want to get at this guy. So I've got to separate that guy from the base. So I can do that using our power rule for logarithms. So take the log of both sides. And we'll use natural log again because it's so easy to work with. So we take the natural log of 3 to the power of x minus 2, and that equals the natural log of this entire quotient, 12 divided by the natural log of 3. And then I can take this exponent and move it out front. Okay, so we get x minus 2 times the natural log of 3 equals this guy here. Now, I know coming down the road when I punch it into the calculator, I am probably going to want to make it easy on myself. You don't have to do this. I'll do it. You could leave this just the way it is right there if you want. But notice I have the natural log of a quotient, so I can apply the quotient rule, and that'll give me the natural log of the numerator minus the natural log of the denominator. So this right-hand side would be the same as the natural log of 12 minus the natural log of 3. And again, you could leave it the way it is. It's up to you. Okay, so now we divide both sides by the natural log of 3 to get x minus 2 by itself. So x minus 2 equals the natural log of 12 minus the natural log of 3, all divided by natural log of 3. Okay, and then notice I'm going to have to add 2 to both sides. Okay, so x equals natural log of 12 minus the natural log of 3, all divided by the natural log of 3 plus 2. Okay, so I'm going to punch that entire thing in my calculator, and so I want to separate this numerator from this denominator. So when I punch it into the calculator, I'm going to use some grouping symbols there. Okay, so let's see what happens when we punch that in. Okay, so I got a grouping symbol, natural log of 12, grouping symbol after the 12, minus the natural log of 3. So I got a grouping symbol for the 3, a grouping symbol for the natural log of 3, and then a grouping symbol to separate the numerator from the denominator. Then we say divided by the natural log of 3 and hit enter. Okay, and then I add 2 and hit enter, and I am getting roughly 4.18 when it's rounded off to the nearest hundredth. Okay, so that is our x coordinate. Okay, so now I got to find my y coordinate. So we've got to bring this guy, okay, down here. Okay, and my y coordinate ends up being y equals 3 to the power of 4.18 minus 2, and then we subtract 10 from that. Okay, and obviously we're going to have to round things off. So I'm just going to use my calculator, my little caret, and some grouping symbols, and we're in good shape. So let's see, 3 to the power of, parenthesis, 4.18 minus 2, parenthesis, hit enter, and then subtract 10. And when I round off the nearest hundredth, I'm getting roughly about 0.97. Okay, so notice how much quicker this guy went after we did one of these yesterday. Okay, pretty straightforward. And again, if you take a look at this guy right here, okay, that guy right there is the same as this guy right here. So if you want to leave that numerator in this form, you can do it. You just, again, when you come down here, the form of that numerator is going to be different. So just be careful with your grouping symbols when you're punching it in your calculator. Otherwise, it's, you know, just as easy. It's just a matter of how you want to do it. Okay, so let's see. We want to get into some integration, okay, with exponentials. Okay, so we go back to our original rule, okay, dealing with derivatives, okay, and we can actually derive a formula for integration. Okay, so let's see. Okay, the derivative of a to the x power would be a to the x times the natural log of the base a times the derivative of the exponent, and the derivative of x is just 1. Okay, so how about if we take the integral of both sides? Well, if these two sides are equal to each other, and I take the integral of both sides, obviously the integrals have to be equal to each other. So let's see, I would get the integral of the derivative of a to the x has to be equal to the integral of a to the x times the natural log of a. Now, we know that derivatives and integrals are sort of opposite functions of each other. So they would cancel each other out. So that means these guys go away, and I'm just left with this a to the x. So that means the integral of a to the x natural log of a has to be equal to a to the x. Okay. Okay, now, the natural log of a is just a constant. Remember, in this exponential, okay, that base is just a constant. So the natural log of a is just a constant. So this is just a constant multiplier. So why not divide it out on both sides? And so obviously it cancels off over here on the left-hand side, and I get the integral of a to the x equals a to the x over the natural log of a. And then all I have to do is add in my dx right here, and then my constant of integration, and we get a formula for integrating an exponential. Pretty cool. Not hard at all to work with. Okay, so we should be able to apply that to a number of problems like this. Okay, now, the first one is the easiest one, and they get a little bit tougher going all the way down. Okay, first one is real straightforward. Okay, so if you take a look here and take a look here, notice that the exponent is x, the exponent is x, so really all we need to do is use the fact that a is 10 and just apply this formula. Okay, so let's see that first one. 10 to the x power dx. Okay, we're going to integrate that, so we just go up here. Okay, so it's going to be 10 to the x over the natural log of 10 plus our constant of integration. And take a look at that, and there's really nothing else I can do with it, and you're done. Okay, it's that simple. Okay, just applying a formula. Okay, this guy is just a little bit tougher, not a whole bunch. Okay, just a little bit. Okay, but notice rather than having an exponent that's just x, this guy is x plus 4. Okay, so I am thinking, why don't we use a little bit of u substitution? Okay, so we say, okay, let's let u be the exponent, x plus 4. So du would be the derivative here, so it would just be 1, so 1 dx or just dx. So substituting, we're going to get the integral of 5 to the uth, and then dx and du are the same thing, so that would just be du. Okay, so now we use this and go right back to the formula. Okay, so that's going to give us 5 to the uth power over the natural log of 5 plus c, and then we go back and just substitute our x plus 4 for u. So we get 5 to the power of x plus 4 over the natural log of 5 plus c. Real straightforward, okay? Really straightforward. Okay, so something tells me these guys will get a little bit tougher. Okay, not a whole bunch, but a little bit. Okay, but again, we just keep going back to that same rule. Okay, so let's see this third one down. The integral of x times 4 to the 2x squared power dx. All right, now I'm thinking u substitution again. And just like up here where I let u be the exponent, why don't we try that down here, let u be the exponent. Okay, so if we go, okay, our u is 2x squared, then our du is 4x dx. Okay, now I have x dx right there, so I just want to get rid of that 4. So I get 1/4 du equals x dx. Okay, so we just go back in and substitute and see what we can come up with. All right, so let's see. All right, now my x dx is this 1/4 du. And then my 2x squared is u, so this is just 4 to the uth. Like that. Okay, well this 1/4 is a constant multiplier, so just move that out front. And then we have the integral of 4 to the uth power du. Okay, so here's where we just go back to our formula right here. Should be no big deal. Don't forget the constant multiplier out front. 1/4 times, that would be 4 to the uth over the natural log of the base 4 plus c. Okay, and then we can substitute back in. So that is going to be 4 to the 2x squared power all over 4 times the natural log of 4 plus c. All right, now I would say that that is certainly one acceptable form. And as I'm looking at it, I'm kind of drawn to that denominator, okay, because I have a logarithm and I have a coefficient, and so it looks to me like I could take that coefficient and move it back as an exponent using my power rule. So I could write this as 4 to the 2x power all over the natural log of 4 to the 4th plus c, and 4 to the 4th would be 16 times 16 or 256. So another acceptable form of the answer would be 4 to the 2x squared power all over the natural log of 256 plus c. And we just have a different form right there. I'd say both of them are 100% correct, so it's just a matter of which one you want to use. Okay, let's bump down to these bottom two, and let's see what's going on here. Okay, so let's see. We have the integral of cosine of x times 2 to the power of the sine of x dx. So again, just like the previous two, I would think u substitution is going to work out. Okay, so let's see. Just like the previous two, where we let u be our exponent, why don't we try the same thing here and see if that works? Okay, so if I let u equal sine of x, then my du is cosine x dx. There we go. Okay, so there's your cosine x, there's your dx, that's your du. So we're in good shape here. Okay, so this guy becomes 2 to the uth du. And all we have to do is go here, apply our rule, and we're in good shape. Okay, so I would get 2 to the uth over the natural log of 2 plus c. And then just go back and substitute sine of x in for u, and we should be okay. So 2 to the power of the sine of x all over the natural log of 2 plus c. And I'm looking at that guy, and I don't see anything else we can do with it. That would probably be the only final answer that I would work with. Okay, so that one's pretty straightforward. So let's go down to this bottom one. Let's see what's going on here. Okay, so I have the integral of the sine of x times 8 to the power of cosine of x dx. Okay. All right, so I am thinking, let's approach it just like we did the last couple, and let's let u be our exponent, cosine of x. So that means du ends up being the opposite of the sine of x dx. And notice that takes care of sine of x and dx. I just have to get rid of that opposite. Okay, so the opposite of du is sine of x dx. Okay, so we go back and we substitute. So I have 8 to the uth times the opposite of du. So that factor of -1 is just a constant multiplier, so I just move that guy out front. So we get the opposite of 8 to the uth du. And then we just go back to our formula. Okay, don't forget your negative sign. So that's going to be the opposite of 8 to the uth divided by the natural log of 8 plus c. And then we go ahead and substitute back in. Our u is cosine of x. So we get the opposite of 8 to the cosine of x power all over the natural log of 8 plus c. And then I'm taking a look at that guy and I'm saying, okay, that certainly seems like it would be one acceptable form for the answer. Is there anything else I can do? Well, I'm thinking, what if I take this negative sign and put it down in the denominator? And so it acts like a coefficient of the natural log of 8. And then I know I can use the coefficient and put it back in exponent form and see if there's something I can do there. Okay, so this would be, let's see, 8 to the power of cosine of x all over the opposite of the natural log of 8 plus c. Okay, so I bring that back, it's going to be 8 to the negative first. And 8 to the negative first is 1/8. So this would be 8 to the power of cosine of x all over natural log of 1/8 plus c. And I would say that is another form of the answer, which would be completely acceptable. Now, somebody might take a look at that denominator and say, okay, I got the natural log of a quotient. Could I apply the quotient rule? Well, of course you can. Will it make a difference? I don't know. Let's take a look at it. Okay, so we have 8 to the power of cosine of x all over, applying the quotient rule, that'd be the natural log of the numerator minus the natural log of the denominator. Natural log of 1 minus the natural log of 8 plus c. Now, the natural log of 1 is equal to 0. Okay, so this takes us right back to 8 to the power of cosine of x all over the opposite of the natural log of 8 plus c. So notice it doesn't help us out. Okay, it takes us right back to here. So it doesn't really do anything there. So I would say that this guy is 100% acceptable and this guy is 100% acceptable. Okay, that should wrap it up for this week. You guys got a quiz. I'm pretty sure it's due on Monday. It's right on Google Classroom. Now make sure that it's turned in on time. If it's turned in late, you're not going to get full credit for it. Okay, and it's not homework. It's not credit, no credit like homework. It's going to be graded, so do your best on it. You guys stay safe, stay away from the zombie virus, and I'll talk to you soon.